stuff with using KERAS. Okay, so hope you guys are aware of KERAS, right? So first of
Um,
all, we just want to understand why do we need KERAS?
Actually, Satish, we don't know. I mean, most of I think many of us don't know what is KERAS. If you can just quickly do something on that,
Yeah, sure.
and even TensorFlow, I don't know actually.
Okay, so Keras and TensorFlow and all, like it's a APIs. Um, it is mainly used for distributed computing. Like we have lots of data needs to be processed, but when it comes to Python, it's a single um, system, right? So if you load any data set, that would be in memory. That's a single in memory system. But when it comes to production, the volume of data is huge, so you cannot load entire data into in memory. So that's why they have introduced distributed computing, where in which the data will be split across the different disks or different altogether different systems in terms of part files. We call it when it comes to Spark and big data. So they'll call it as a uh, the file will be divided into different parts, and then when it processing the data, then it will consolidate and then it will be um, processed. So that's another uh, way of looking at Keras, and uh, this is for this is not for machine learning. This is for developers experience. So if you use any framework like Keras and TensorFlow, it's going to be very modular. Like you can use TensorFlow model with any of the services. Like you can deploy it in AWS, Azure, GCP, anywhere. You can just deploy it. Right. So Keras is initially it's a API, right? It was separate library altogether, but later TensorFlow acquired it. In TensorFlow 2 onwards, the backend it's going to be TensorFlow. That's the default backend, and then the wrapper around TensorFlow is Keras. That's high level APIs to utilize from different services.
Oh, so okay. So if I understand this correctly, it's made on top of TensorFlow or some other framework, right? Keras is on the top of that, right? Like
Right, right. Yes.
Pandas is on top of maybe like NumPy, right?
Yeah, exactly. That's a exact. Like we have different backends, like not just TensorFlow. We have Thanos and lots of other. I'll show it. There are lots of backend which actually does that heavy lifting. Like it will process the data, but Keras is like it's outer layer wherein which it's a modular. Like different parts of uh, uh, model, different models will be available. Like if you want to deploy it, the Keras it's very handy
Hmm.
into the production environment, and like the actual core logics in would be sitting in the TensorFlow, but uh, production and ML ops, this kind of thing will be easy when you go with the Keras.
Okay, okay. And similar to Keras, some other thing is also available, or is it the only one on
No,
top of?
there are lots of other things as well, but I heard something like yeah, TensorFlow itself can do the things whatever Keras is doing, but it's like
Complicated.
but yeah, TensorFlow will be having the computation part, but Keras will do that the modular part very well as compared to TensorFlow.
Okay, fine, fine. Thanks. Yeah.
Okay, so moving on, it's like Keras is there are lots of community available, and the people are like using it very well, and then it's keep on evolving. Okay, and okay, so here when it comes to Keras, you can build a product, and then you can deploy it into mobile app, like Keras can be used as a mobile app and then web application, and then if it needs to be used as a web app, that then it can be used. So these are the integration they can do it. But let's say like you wanna integrate the backend computations, like whatever you're trained and modeled the model, right? So whatever the model we are building it, and if you wanna uh, integrate with any of the web application, then Keras will be very useful, right? So but when you go with any other the raw machine learning algorithms like the KNN or ANN or CNN, then there's no way to integrate any of the web application with the actual core, the machine learning algorithm. So whatever the product, whatever the end goal we just developed using ANN or CNN, which can't be integrated with any other web application or any other outside world. That's going to be a unique engine. But if you want to integrate with other world, then other systems, then we can go with Keras, right? And then again, this is what I told. Like there are multiple backend engines and available like TensorFlow and then Thanos. Those are other backend engines which would be doing the actual heavy lifting logics. And then yeah, so when it comes to Python and all, right, it would be running on the CPU. But when it comes to GPU, like it's a kind of right, distributed computing. So it can run on GPU as well, so that it will be very performant. And then
Sorry,
okay,
sorry. What is GPU?
like right, CPU central processing unit is this is a graphical processing unit.
Yeah. Okay. So
So
it's not. It's not
if you wanna
related.
process image,
Mm-hmm.
yes, Manoj.
Sorry. It's like GPU is not related to distributed, right?
Yeah, that's right. But it's a kind of graphical stuff, right? If you wanna do any image processing, and then those kind of graphics, like if you wanna, right, you need GPU for some of the gaming stuff.
Yeah. 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 So same thing. Okay. Okay. Okay.
Same thing.
Okay. Right. Yeah.
And also like GPUs can different GPUs can work as a cluster, and then it can share the things across the different machines.
Oh.
So
Okay.
again, it's a distributed training support
Okay. Okay. Got it.
with the different GPUs. And TPU also is another things with which wherein which the Keras can run on.
TPU. What is
TPU, I just like another level of processing units. Like
It's
I'm not
tensor
sure.
processing unit, no?
Yeah. But I'm not sure about. And I never used it. But there are
Tensor is a
advanced.
data structure actually. When you speak of matrix,
Okay.
matrix itself is a tensor. They call it in computer science. Computer scientists call it as tensor. It is a data structure in itself. So,
Yeah. So
matrix is by virtue of its own architecture.
yeah, it's a kind of advanced processing units in computer, like right. So the vision APIs, those are the advanced things which is making use of these TPUs.
Invented by Google.
Yeah, that's right. But we didn't come across those kind of things so far. But we can actually make use of TPUs uh, with Keras. Like Keras can run on TPUs. I'm not sure like our Python notebooks can run on it, but the Keras can do. Okay, so moving on, these are the different companies which is um developed 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 that Keras. Okay, and still there are lots of ecosystems they are developing it. Right? That in NVIDIA, like you must have seen this in your laptop itself. The graphic provider, they are also involving in it. Okay, so it's a high level neural network API. It's a API just to interact with different system, and then bringing different systems or different algorithms under one umbrella so that we can build better product. So again, it's run on Python. Right, these are the different backends: TNO, TensorFlow, or CNTK. I am not sure about what is CNTK, but I have come across TensorFlow and TNO. These all are the ancient machine learning libraries, the TNO, which does lots of computation and heavy lifting for us. So modular, it's again a key purpose of KERAS. Different parts of application would be running individually, and then it can interact with each other using APIs. And fast, yes, with the use of distributed computing, and then easy to use. So right, so these are some theory part. Um, okay, so it's a level. It doesn't handle low level computations, which would be which would be taken care by TensorFlow or CNTK or Theano, but it relies on the couple of frameworks like it will be uh, kind of wrapper around any of the products so that it can be um, easily accessible, right? Okay, so moving on, that's a kind of wrapper, that's what they are saying it. And when it comes to KERAS, there are two models available. One is sequential models, and another one is functional models. Sequential model is a very straightforward one. Like with we had learned at CNN, like input layer, hidden layer, and then output layer. It's a sequential one by one, like one after other. Like once you run that for layer one, and then the output would be consolidated using different activation functions, and then it will feed into the next level of hidden layers. And then in layer 2 there will be uh, some other functions would be taken care with the different weight and then different bias, and then again it will give back to consolidated and then give back to the output layer. It's a level of sequential steps in Keras. And then we know, right, a conventional layer and one above the other. This all are already we had learned it in our ML class. Okay, so that's the first one, and second one is functional. Functional is like kind of if you wanna build any complex model, wherein which we need multiple back propagations and then different level of uh, weight and regularizations, then we need to go with the functional models. That's a kind of overview. So these are the just a code snippet. Already yesterday also we had see these kind of things. Dense is it's a layer, like whether it can be dense in the sense right. So each and every node would be interconnected, kind of Cartesian product. So using these Keras layers package, we can use dense activations. And if you want to build a sequential model, this is what you can create: dense with 32 node. And then yesterday also we had seen this input shape 784, and activation is relu. Relu we already had discussed it. And then like after that it will create another layer and then different activation functions. So we are pretty much aware of relu and softmax. And also we can do
Just
in
can
this.
you brief about Relu and Softmax? I will just recall to everyone.
Okay, so I'll try my level best and then correct me if I'm wrong, Manoj. So relu is a I mean, it's activation function. What it does, like, it will give you certain values between 0 to 1. So let's say we are providing in this case 32 inputs, and then as a single consolidated value out of 32, whichever value is falling and falling in between 0 to 1. Let's say like the first would be 0.01 and second input will be 0.8, third would be 0.9, and the fifth 31 would be 0.8. So it's a range between 0 to 1, um, with the different values,
Yeah,
right?
just to add to it, like we have the other function, no, that's of, I mean, what was that?
Softmax,
No, no, 0 and 1 sigmoid. Sigmoid gives
sigmoid.
just two output, right? So
Yeah.
in the ReLU we
Right.
have 0 to 1 linear output.
Yeah, 0.1, 2, 3, 4, 5, like that it will give you.
The
It's a
probability, is it? Probability.
no, it's not a probability. Probability like the softmax. Softmax the probability.
Yeah, because yeah, yeah,
Softmax.
it's a, yeah, I think ReLU is a probability, right?
No, it's not a probability. Relu, it's like if you add up all these points, it would come to 1. That's called probability, right? But Relu, um, if you add up all those points, then it will not come to 1. So that's not a probability. When it comes to softmax, it's a probability. They can add 0.8, 0.9, 0.10, but again, right, the softmax formula is exponential of variable divided by sum of exponential of variable. So again, they will bring back every values within 1 with the probabilities.
Okay, okay. Things, yeah.
So Relu is like Relu. What it does, like it will filter out only 0 to 1 values. The minus values will be knocked out.
Okay.
So that's my understanding. And also there are lots of Relu's activation function like leaky Relu, P Relu, and lots of things which maybe we need to learn, because right now some cases wherein which if we need to allow couple of very minor negative values like 0 minus 0.1 to 2, in that case they will be using leaky Relus. Okay. Is it
Yeah, I
clear?
think fine. I think I think it is a fair idea on this.
Yeah, maybe we can dig deeper, and then tomorrow if you're clear enough to explain, then you can do it in the next class.
Okay, yeah, I think we can. Thanks.
Okay, so these are the ways we can create different layers. Model.add, you can do it, or otherwise you can put those different levels of layers into the arrays, and then it will get created, right? Yeah, this is the functional models. This is for complex models. It's like multi-output models, like function sequential models. Like anyway, we'll end up with sigmoid 0 and 1s, or most probably like softmax. That's a major activation function we can expect for sequential. But when it comes to multi-output models, uh, the functional models will be used, and directed acyclic graphs, meaning we will be doing multiple level of epochs iterations with different batch levels. Like first they will be doing some computation with 100 batches, and then they will check the output, and then if it's not working out, then they will change the different batch, like 1,000 uh, inputs at a time, and then they'll keep on doing different batches and different epochs. So that's why they call it acyclic graphs. And the shade layers, again, the shade layers, different models can be shade for single output or single purpose of the machine learning output which we are expecting out of that. So these are some complex the machine learning algorithms would be used here with the different layers between different models. Okay, so these are the straightforward thing: input, output models, and then there are unique aspects of Keras API. Defining input, yeah, we know that. Connecting layers using uh, dense, uh, like right, that's a kind of Cartesian product. Each and every will be connected. Each and every node would be connected to each other, and then finally we create a models with a combination of input, layers, and models. So defining input, uh, we have to create, when it comes to functional model, we have to define a standalone input layer that specifies the shape of the input data. So when it comes to sequential, the input can be uh, anything, but when it comes to functional, we have to define the shape. So and also input also can be a tuples, the combination of pairs with the different dimensionality of data. So again, right. So sequential is like one dimensional, but if you wanna um, solve the purpose of multi-dimensional, then we can go with multi-dimensional input data with the tuples, or that tri stimulus with the three values, or quad. So those all are the input types. We can use it for functional models. So these are we have already learned about multi-layer perceptron, the shape, and the different level of batches, mini batch, or the whole batch, like one at a time. Whole inputs would be fed into that the models, and then we will train the data, uh, and like we can also split the data with the help of batches. So these are the ways you can define the shape, right? So this is a two. I think it's a one dimensional, two comma. But if you want to have multiple shapes, then you can add it.
This sequential and function means something parallel and series like that or something. One by one it will do in the sequential, and in the function it will all do together or something like that. Or
Yeah, yes, you are right, Manoj. Like sequential is one by one, but when it comes to functional, the different layers will be working independently, and then they will consolidate.
oh,
It's
okay.
a kind of distributed parallel computing.
Okay, so like in the sequential, I just want to understand like one hidden node will be generated and then it will be destroyed, and a second hidden node will be generated or something like that, or
In functional,
yeah, in sequential.
no. The layers would be available.
Uh-huh.
Layers would be available, but there are some concepts like regularization. Like let's say if our model is underfit models, then there are lots of regularization techniques available in KERAS, like drop ports, data accommodations. Like let's say if we have 10 inputs, and then each and every epoch, there are some random input layer will be removed, and then they will check the output, and then the next epoch, right? So it's a kind of iterations. So in the next iteration, like out of 10, let's say in first iteration, 3 and 4 nodes will be removed, and then the the iteration will be going from input to hidden to output, and then the next back propagation, the next epoch, the fifth and sixth node will be removed, and then they will be doing that iterations, and then they will try to um, provide different or more training data to avoid overfitting, or in case of underfitting, they will be they'll try to capture more features or try to understand the input layers better to provide better models.
So in the sequential, it's related to this regularization. What you say in the sequential, or is it something else? Sequential versus functional. Yes, I just want to understand what's the difference.
So regularization is like it would be available. It would be useful for in both the cases, sequential as well as functional.
Mm-hmm.
That's once you build the model, like whether after we got that test results, then we will be doing that regularizations based on
Yeah, yeah,
the
yeah.
model is
Okay,
how the model is.
yeah, right. So I just want to know what is the quick difference between the sequential and functional. Is something we can?
So that's why, like, if it's a straightforward simple models, then they will be going with sequential models. But functional models, like it's a complex models, like shade layers, as you said, like it's going to be uh, a parallel way of computing. Like it would be running in parallel. Different, like let's say the different hidden layers would be running in parallel, and then they will consolidate it.
Okay, okay. So it's more complex. Yeah, functional.
Yeah,
Okay,
yeah.
okay.
Okay. Okay, so we already had seen this one, and then yeah, connecting layers. Uh, there are, right? So we have hidden layers, and then input hidden, and then output. There are in Keras there are connecting layers as well, where in which where the input comes from while defining the each new layer, right? And then there are different bracket notations used to specify the layer from which input is received to the current layer. So where it's coming from and where it's going to, these are the kind of metadata would be available in the connecting layers. Which node is connected to which node of next layer, next hidden layer. So these are the kind of additional layers available in Keras. Always think that we'll have only input hidden and then output, but these are layers also available. So it's a kind of just a connectivity. Here you could see that, right? Here we have input layers and then dense layers, and then we have stored this visible layer, and then we fed that visible into dense layer too. So this is called the connecting layer. And then after that we can create a model. After creating all of our model layers and then connecting them together, you must define a model. So I mean that's what we are ultimate goals, right? So after we got that visible and hidden layer, and then we just need to create a model with that input as a visible and output as a hidden. So just a library. How do we use it? That's what I'm trying to show. So these are the different predefined neural network layers available in Keras. We might have we just learned only input, hidden, and output in between some activation function. But when it comes to Keras, we have these many layers: core layers, convolutional layers, pooling layers. Pooling, we are aware, right? Pooling, padding, strides, and there are other concepts available. So each and every the areas which would be used in this CNN would be available as a separate layers here: locally connected layers, recurrent layers, then noise layers.
So these are the hidden layers, is it?
It's not just hidden layers. it's a predefined layers already available as part of KERAS. If needed, then we can use it.
Okay.
Let's say like if you want to merge two different layers, then we have to go with merge layers. Even I'm not 100% aware of it, but I just learned it like these are layers available. Like
Okay.
noise layers, we already knew that. That's a loss, and we have advanced activation layers as well. It's kind of predefined, ready-made layers available. If needed, you can just use it and plug and play. But when you use that, if you wanna create some these kind of layers using CNN, then you have to write a Python code, right? But when it comes to Keras, if you import just Keras core layers, then you just need to add it into the model. Whether it can be sequential or functional, you just need to plug and play.
But KERAS is still again a Python code only, right?
Yeah.
Python code implementation.
Yeah, internally Keras was developed using Python only, but it's a kind of yes.
How we use it? Sorry. Okay.
Yeah, go ahead.
How are these layers different from hidden layers?
Yes. I mean, in place of hidden layers, we had seen that this one, right? The recurrent layers and all. Okay, here we had seen that connecting layers, right? So this is something to connect different nodes. So there are some scenarios where in which we need to connect different nodes, right? In sequential or functional model. So for that we have here you could see that keras dot layers at input. Likewise, we would be having these many layers: core layers, convolutional layers. I think it would be part of hidden layer, but it's not 100%.
Layers, you mean to say?
Sorry.
Different types of hidden layers.
Different type of I won't say in that way, because Keras is a API. It's a library, right?
Right.
So it has these many layers. It's available in the library. You can straight away use that. In place of hidden layer, yes. In place of hidden layer, you can use it, but you can call it as hidden layer. That's where the actual stuff is happening, right?
Right. Okay.
And normalization layers, we know, right? Some cases where we need to normalize the data for generalization. So maybe if you go with some use cases, we would be knowing it. But let's say this pooling layers and all, right? Pooling, like let's say if you are going with 3x3 metrics, and then if you are going with one rows at a time using strides, and then two rows at a time, and then let's say I can edit. Let's say we have 3x3 matrix. Sorry, 4x4. Let's say we consider it as a image processing. We have these many pixels. So right, the strides, like they will be taking this many matrices or layers, and they'll be doing the computations, and then they will take this particular layer, and then they will be doing some computation, and next they will be taking these layers, right? So these are the pooling thing, but there are some challenges around it, because there are some border problems, like, so this will be this particular layer would be available for computation twice, but these will not be available. So for that, what they will be doing, they will be doing some padding kind of with 0, 0 here. They will be adding some additional layer, and then they will be starting from here. So 2, 2, and then next iteration they will be going with these things. So these are the concepts available ready-madely in KERAS APIs. I think it would be part of hidden layers, but I'm not I'm not sure, like, can we say in that way, because it may be useful in some other areas as well, in output layers also, because the noise layer, the normalization layer, right, that can be used in output layer also. So that's what my understanding. Maybe we can uh, learn more, and then we can get our doubts clarified later. Okay. Okay. So again, when it comes to regularizations, right. So after we build the model, like if there is any issues with underfitting, overfitting, then we need to go with regularizations. We know, right, underfitting, what is underfitting and overfitting and all, right? Hello?
Yes, yes.
Right. So underfitting, quick things like we have training accuracy and testing accuracy. So if training accuracy is 60, and then if testing accuracy is again, it's coming around 61, then it is not covering 100%. So 40% of the feature is not um, actually trained, right? So only 60% of the data is being used, and then we have got 60% accuracy. So this is underfitting. And then when it comes to overfitting, in training we may get 100% accuracy, but when it comes to testing, it will be coming 50%, meaning, so we have we didn't do any generalizations. We just went with each and every consider each and every data points, and then we built the model. So appropriate is like kind of training, it's 90%, and testing, if it's coming around 89 or something, then we will call it as appropriate fitting. So these are the challenges we have in almost all the models. Just by doing kind of some metrics like accuracy, we can get to understand like whether the model is underfitting or overfitting. So appropriate fitting is fine, like just okay. So that's so if you want to do that regularizations, so you could see that, right here, the error is coming down when the model complexity is very less. Okay, so when the model complexity is increasing with the training set, then in test, then the error also getting increased. So this curve, like, so we have to find a optimum complexity so that our models will be appropriate. So we need not to go with high complexity with the training, and then the error will be increased. Yes. Okay. Okay. Yes. Yes. That's right, Manoj. So overfitting is the one of the um, problems in data science world. Okay. Training versus test set error. Okay. So like, how does the regularization help to reduce the overfitting? So right. So this is overfitting, and then there are different hidden layers. We can do this by different regularization techniques available in KERAS. One is um, so here we have to choose the regularization coefficients wisely. So we should not be very large, and also it should not be very less. So again, here also we have to find the optimum regularization coefficients, so that the weight will not be uh, more or high, which definitely will end up with the overfitting. Okay. So moving on. So if you are, there are different techniques available to avoid overfitting. Uh, let's say, like, we have these many layers. So already I had explained this one. And in every iteration, there will be some random selector nodes will be removed, and then they will be doing some computations. So let's say if you are getting overfitting by removing these two, how the model is behaving, then we will observe it, and then the next iteration, these two will be available, and these two nodes will be removed, and then we will be doing this iteration epoch, and then we will observe that. So this is the regularization technique. It's used to avoid overfitting. Okay. It's kind of, they call it as ensemble techniques. So different uh, level of algorithm put together to get better results. Okay, so when it comes to dropout, there are some percentage we can define it, uh, like how many percentage of nodes needs to be dropout using KERAS. If you put p equal to 0.5, then if we have four layers nodes in the hidden layer, two will be removed for one epoch, and then the next iteration, the left out node will be removed, and the previous left out would be added. So we can define the dropout percentage. If we put 0.2, then the 20% of the node will be removed on each iteration, and then we'll be observing the results. So in that way, we will have more randomness in the data to mimic the actual test scenario. Okay, sure. So we'll disconnect from here and then we'll join there, right? Oh, once disconnected. Okay. Okay, so this kind of probability, like how many layers randomly will removed, that we can configure it using probability. Like here you could see that, right? So dropout layers are altogether different layer in between input and output. It's not part of a hidden layer. So that's what I was trying to explain. Likewise, we can add normalization layer here. But when it comes to CNN, we just learn the basics: input, hidden, multiple hidden, and then output. But when it comes to KERAS, there are likewise we have different layers. This is a dropout layer. So dropout can be applied to both hidden layers as well as the input layers, right? So the different layers would be used in anywhere input or output, anywhere if it's necessary. So dropout is preferred in large neural network structure in order to introduce more randomness. So more randomness, right? So more randomness can be calculated using entropy. But here also the same kind of concepts, like they want more randomness so that the models will get trained to solve any scenarios. So am I still, we are on call, right? Okay.
Yes.
Okay, sorry. Okay, dropout. This is the code, right? So we can just layers core. So dropout is part of core layers. So we had seen different layers, right? So here the dropout is part of the core layer. So it's not just a hidden layer. I think it's so meaning so that this dropout layer is already pre-built in Keras layers package, and then all we need to just import it, and then you can just add it here. You could see that, right? After input dense layer, you just need to add it dropout. So after this input, 25% of the nodes will be removed, and then 75% of the nodes will move to the next level of hidden layers, right? So here you could see that output dimensional is hidden 1 units, input is this one, activation is relu, and then softmax layer in the output. So I think it's a multi category output. So and then this is another regularization technique to avoid overfitting. So we can right, the simplest way to reduce overfitting is to increase the size of training data. So that the testing, most of the testing scenarios will be covered. So if the testing 100% of the testing scenarios covered, and then all the again the similar kind of scenarios is the data points is available in the test data sets, then almost we will get equivalent accuracy between test and training, right? So that's why they wanted to increase the size of the training data, so that most of the testing scenarios would be covered in terms of data. Okay, so here what they are doing is like, if they, let's say they are doing some image classifications, two can be like this, two can be like this. So we get just 1 2 with the help of data accommodations. The two can be transformed with these two, meaning they are just rotating, and they are just changing the scale. And in this case they are just shifting it in the upwards, and in this case also they are shifting 3 in the lower side, and then this is shear, and then shift and scale combination of rotation, and these are the uh, techniques they will be using to create more data. So there are rotating images, flipping, scaling, shifting. With this, these are the pre-built options or libraries available in part of KERAS, and then you can after we do this one, then we can use that data as a training data. So this is a transformation, like some handwritten one. We'll look at it, the code size. This technique is known as data augmentations. This usually provides a big leap in improving accuracy of the models, of course. So these are the kind of tricks in terms of regularizations to mimic different scenarios while testing it. So this is the code. We have Can we start? Okay. So we have a image data generator class available in KERAS as part of pre-processing. So this is what I meant, like the ready-made the libraries options available as part of KERAS. This will be used here. You could see that, right? So they are passing flip through horizontal, so they're going to flip it horizontally, and then they are trying to use it as a train data. Okay, I think that's it. Maybe I have some neural network notebook to predict the diabetic to predict the user is having diabetics or not. So you could see that, right? So we have sklearn. You guys are aware. This is what we import sequential model, and then dense layers. Show you this one. Okay. So what can be tuned in neural network? So hidden layers. So we can play around with different hidden layers with different activation functions, weight initializations, and then learning rate and momentum, and optimization algorithms, batch and epoch. Batch is like how many nodes at a time, or how many data set at a time, and epoch is how many iterations we can have. So epoch is critical one. Like if you have more number of epochs, then there's chance that the model may overfit. So we have to everywhere we have to find the optimum count. So I'm just reading this one, diabetic data. Right? So we have different features: glucose, blood pressure, skin thickness, insulin, BMI, and this diabetics pedigree functions, age, and these are target values. We know that we are getting predictors and response, independent values and dependent values separately, and then this is where KERAS, like we have separate method in which we create a model, a sequential model, and then I'm adding first layer with 12. We have 12 inputs, 12 nodes, and then we have 8 1 2 3 4 5 6 7 8 independent values, and we are using it LU. And then we are adding one output layer with one node activation functions sigmoid, so 0 and 1. So the output is 0 and 1. That's why we had used um, the sigmoid activation functions. And then my model compile and loss is binary cross entropy, since it's a classifications uh, problem. Then we went with binary cross entropy, and the optimizer is Adam. We need to learn more about this optimizer. We have a number of optimizers. Um, so that anyway we'll do it later. And then yeah, yes. And there are a couple of other optimizers as well. Adam, GCD, GCD, something. There are lots of things. Maybe I'm aware of SGD, but I'm not sure about Adam what it does. Stochastic gradient descent. We learned it to find the local minima. So anyone aware of what is
To reduce
gradient?
the loss function only, right?
Sorry.
Optimizer is basically used to reduce the loss function
Yeah, yeah, definitely it will reduce the loss.
and find the local. Okay.
Yeah. So anyone aware of what is gradient? We learned about.
It's the second,
Manoj,
second
your voice
differential
is breaking.
function, right?
Sorry, come again.
It's the second differentiation of a function, like a surface, given surface in a 3 dimension or an n number of dimensions. It can be an n-dimensional thing. If we differentiate it twice, that gives us the gradient, and the direction the tensor is in the upward direction, with respect to which we are taking that second derivative.
Yeah. So derivative of like
Second derivative of the
yeah.
function, of
So
any function.
gradient. Yeah, you're right. So gradient is something. Let's say we have uh, glucose with respect to um, sugar. So meaning that how the glucose is affecting this sugar, right? So that's called gradient. The rate of change, how the one feature is affecting the other, right?
Is it the other way around? I mean, is it not the other way around? I mean, given the change in sugar, how much it is changing the glucose?
I think target would be coming here, right? Um, so is it other way around? Like
It is
how the
other way around, because delta y by delta x. So given the change in the x-axis, how much your y-axis will change, that is the derivative. And when we put the limit of x to 0, or let's say x to infinity, then we get the derivative. When we
okay.
limit of the denominator. For example, for this particular thing that you wrote, for the change in the level of sugar, we will put that limit of sugar delta to 0. So the x-axis will be sugar and the y-axis will be glucose. Given the small change in sugar, how much our glucose level is changing. If it is linear, then it will have a slightly upward direction, or if it is negatively linear, then it has a downward direction.
Okay. So may, can we call slope as a gradient
Yes,
then?
it is slope. No, exactly that. That is the first derivative. The first moment of any function is the slope. But in case of gradient, what you call the second derivative, that gives you the vector, point vector from the Euclidean space. You can say we are in a Cartesian space right now. If we are in a Euclidean space, from that point we will get the vector of it.
Okay, okay. So I mean, I sorry, I didn't get that. What is first derivative and what is second derivative?
The function that you wrote right now, this dou g by dou s,
Okay,
this is first derivative. Okay.
okay,
So in order to calculate the gradient, which we use for the stochastic gradient descent, we our target is to build up the Hessian function, the Hessian matrix. So we take the second derivative of
okay,
the first derivative. Then we get the entire the direction into which this function is moving. You remember in the first semester, we used to take out the saddle point, and if
Equate it
there
to
is
zero, right?
a
We have to
derivative,
equate it to zero.
yeah,
And
for the saddle point, to find the local minima and maxima, we used to equate it to 0, just to
yeah,
get the saddle point, so that we see the inflection point where it is changing the sides at that point. And the basic idea of getting a second derivative is to find that very point in the Euclidean space where it has that vector pointing upwards. And
okay,
for stochastic gradient descent, we usually accompany that entire function with a minus sign, so that we have a gradient descent instead of an ascent, because by virtue of its mathematical plot, it has upward direction. The ascent, the gradient means ascent, the point where it measures itself.
okay, okay. So Euclidean space here, the distance.
Euclidean space is like where your algebra can be connected with the geometry. Like we have made a line, so it has individual dimension, sugar and glucose. You're making a line out of it. That is the Euclidean space. Or you can call it a Cartesian space also, but Euclidean space has more dimensions to it.
Okay, okay, perfect. All the gradient is kind of how one variable is affecting others, right?
Correct.
When it changes. So
Correct.
that's layman way of saying what is gradient. Um, so yes, there are there are lots of buzzwords like this. Maybe we can learn it. Optimizer. Anyone aware of what is Adam optimizer? What it does? Stochastic gradient. We know that it tries to find the local minima. Uh, local minima. Meaning that this one, right? So we have lots of fluctuation, and then if the descent will stochastic gradient will find on each and every iteration it will trying to find the local minima, right? That's what on each and every iteration it does, right?
Uh, yeah, actually, I'm not sure. It is a three-dimensional plot, and we are on a two-dimensional plot here.
Okay, Okay, so maybe Adam, I'm not sure. Maybe if you know, like maybe someone can explain later, maybe. But I'll try to close this one. We had used Keras classifier. We already had seen lots of classification algorithms, but on top of it, so we have to add, right? So here, what I meant was like it, it's a wrapper around scikit-learn. So they have done some optimizations, and then they have added this library on top of scikit-learn, right? So
Even
with
Adam is stochastic gradient descent only. It is adaptive moment estimation. I don't know exactly what how it works, but it uses root mean square for the loss function, and then it uses stochastic gradient descent altogether. Like it's a combined package of RMS and the SGD
okay,
as the
root means
popular approach to use Adam.
okay. But when it comes to classification algorithm, can we use RMSC or MSC?
I don't know. Maybe it depends on the type of the predictors altogether, right? If it is ordinal, I don't think we will be able to use RMS on that because the correlation will be in ranks. Like for example, if you try to find a correlation, you won't be able to use Pearson index. You'll have to go with the Kendall or the other one. I don't really remember the name. So in case of the numerical data, which we call yes, we can use, but in case of where there is ordinal data there, I'm not sure if we can use this Adam
Okay.
thing.
Okay, perfect. So we just compile it. It's code wise. You guys are pretty much aware. Like we just need to use it. We just know what are the methods available. So here in like usually, right? So in the slide, we have seen that we add sequential and then add and then we compile it. But here we have just created a method, and then we just pass that method as a build function. So these are the things um, available. These options are available in Keras classifier, so that this is what we call it as a modular. Tomorrow, if you want to change um, the input layer, and then let's say if you want to change the sigmoid to softmax, then there is no need to change the Keras classifier. You just need to change it to this method. So that's a level of modularity we can avail. But when it comes to Python, it's going to be a sequential execution. Then you have to write different methods. So yeah, tomorrow if
Will
you
it
want
not
to
lose? Sorry, will it not lose the entire training it had learned in the sigmoid if we change the function for say activation function from sigmoid to say softmax? I mean, I'm not sure. I'm asking.
yeah, again like after building the model, we will be training and testing, right? So I mean, after analyzing the results, only we decided to change the activation functions. It depends, right? So anyway, once you make the changes, then again you need to come through that cycle.
And this uses so many epochs. So I am already guessing that in industry they might not be using this grid search CV to find the optimal model. You use every other activation function and every other loss function to try out which one is the best, and then you apply that. Like we have used in the grid search CV here.
So you are saying like in industry they won't be using it, is it?
I'm asking because since the real-time data is so huge and computation is so costly, AWS charges per usage of their
Yeah.
CPU and GPU. So The industry people, they might be very critical about consumption of
Cost.
the computation. Yes, Hannah?
Yeah, yeah, yeah. So, but I think it is the initial stage. Once we
Mm.
find that which batch size is performing good and which epoch is doing good, then we can fix it. But this is for learning purpose, right? So that's why we had used. I mean, we can do that for a training phase, and once we finalize it, and then we can fix it. So this is what I was referring batch size and epoch. So
I
grids, yes.
On what basis are these activation functions selected? I mean, when do we go for ReLU? When do we go for softmax?
Yeah, this question I also had it when we had that machine learning, right? There are
Mhm.
different activation function, but based on the use case, we need to go with let's say like at sigmoid, like for target value is 0 and 1, then we have to go with sigmoid. But let's say if you have multi category output, let's say if you want to find color of the ball, let's say I'm just saying the examples, the colors can be 10. So in that case, we can go with softmax. What is the probability of getting blue this much, red this much? That case, it depends on the use
So
case and
based
the
on
problem
the
statement.
okay.
Problem statement, right? And then in some cases, like ReLU, it's most predominantly used. It's because of it's knocking out the negative values. It always go with positive 0 to 1.
You were telling something about leaky relu, na? How
Yeah,
do they write the leaky relu? Like it is,
yeah.
how do
So
you spell it?
leaky relu. I just read about it because what it does, like in some cases, right, relu it's 0 to 1, right? So
Yeah.
the minus will be minus value input will be removed. But in some cases, some use cases where in which you need to include small amount of negative values, like minus 0 point minus 0 to minus 0.2. In
Mm-hmm.
some values, some negative values you want to include. In that case, you need to go with leaky relu.
Okay. So how
There is
how
no strict
do you remember that syntax? How they wrote that leaky relu?
L. Just they add L. Yes, that's it.
And no threshold, nothing along with it.
And I don't know. Yeah, there should be some threshold. Yeah,
Yeah,
you're
na?
right. Yeah, there
There
should be
should
some
be.
threshold. Yeah, because unless until we mention it, the activation will not be knowing it. I'm not sure.
Okay, maybe later we can
Yeah,
all
we
check.
can, yeah,
Yeah,
dig deeper and then we can understand.
yeah.
And the P relus, there are lots of activation function, man. Like whatever we just learned in ML, it's very um, general one, and the default ones. Relu is the default one. Am I right?
Yeah,
Activation
there is the
default.
first one to change this neural network. The first in the decade who started neural network again. He
Yeah.
really to make this Titanic data set, no? Very
Hmm.
many years ago.
Okay. And yeah, grid search CV. That's another library from model selections. SKLN, that's SKLN one. So we not worry about it. So we ran this one with at the dictionary we have batch size and epoch, and then we can pass that param grids those values, and then it will be CV3. I'm not sure what it does. We If someone can explain it, then that's going to be useful. And once we get that grid, then we can just fit the models using X and Y. So this is what we get. loss is 0.62 percentage and accuracy is 0.67 at the end of 50 epoch. And then if you go up, we get some good accuracy here, 69. It's all about after that we can look at it, and whichever epoch we get good accuracy, then we can fix it.
Mhm.
So apart here, to find the best, you could see that right. The batch is 10 and epoch 50 is what performing well,
Mm.
right? So that's what that's what the grid result it's useful. And then if you want to optimize it, they are going with Adam default. Yeah, Adam is the default optimizer at this point of time. And then we can add sigmoid and then compile it with the optimizer. You can pass whichever optimizer you wanna
You
try.
in the parameter, no?
Sorry.
You pass the optimizer in the parameter itself, no? There,
Yeah, that's
so
the default value.
yeah. So when we start creating the model, we'll have to then pass
Pass
the
pass
value.
it. Yeah.
Then
If needed, if you wanna change it.
yeah, okay.
Okay, again, here also we are decided. So we found that 50 and 10 is the optimum batch size and epoch. So we've just fixed it, and then we are running it, and we gonna yeah. This is what I was referring like ada grad Adam RMS prop. These all are the it's not coming. These are the different optimizer, right?
Mm.
Stochastic gradient, ada delta, ada grad. So we tried with different optimizer, and then we gonna pass the same grid search, and then oh, we can run this one. I think. Okay. Um,
Where are we using tensor library?
like
It is
right?
based upon tensor, okay.
Yeah,
KERAS
yeah.
is tensor.
So what I installed here is like I just installed TensorFlow 2. That's it. I didn't install anything Keras separately. So
Oh,
now
okay.
Keras, if you install TensorFlow 2.0, then you need not install Keras because they have by default uh, Keras is using TensorFlow backend, and they acquired TensorFlow acquired Keras. So now it's one library.
Okay, I understand now.
TF dot something you have to put, but this one is purely Keras. You can use it, but always nowadays the latest one it's coming as TF dot Keras something like that. They get it. Okay, so these are all the different libraries. So that's why it's complaining about. I think so. They want that they have done something in one DNN APIs. Okay, so after trying different optimizer, it looks like Adam is performing well. Okay, that's it. Like if you wanna like right now, it's we are getting just 69 percentage accuracy. So how do you improve it? Maybe we can check that later. Any other questions, team?
Yeah, I have one. Do you guys know how to change the kernel in this Jupyter notebook? I mean, I see someone using different environment for different Jupyter notebooks. Like for example, if I'm running a model for say this diabetes data set, I'll be using a different kernel, different environment, and on another browser I'll be using a different, or maybe the same browser but different tab, I'll be using a different environment. Is it possible to use? Have you seen it? Change kernel, yeah.
Yeah, we
Like
have.
I have only single Python 3 IPy kernel. I don't see any other kernel. But some people use it. I don't know how they use it.
Yeah, I had used PyCharm. There, no, yes,
Yeah.
where, Manoj, in notebook itself. Yeah. Yeah, yeah.
Anaconda Navigator, right? Okay. Let me check.
Here in Visual Studio Code, right? Here you will get to choose the kernel. How can I? Yeah, if you run it, yeah, here you could see that, right? Python 2.7.
In IDE, yes, even I can see in IDEs, but I don't remember how to, get the path and all. I am not really very used to using this IDEs. But here in Conda Navigator, like if I can show you guys, maybe this will
Yeah,
help. Share my
yeah, please.
screen or something.
Yep, yeah, please.
Okay. Window entire screen. Okay. Share. Okay. So this, yeah. So can you see this environment tab? This is what you're trying to say, Manojji? Yeah, this uh, left side. I see share the
Create. No, no, second.
this.
Yeah,
Okay, create this one. Okay, new environment. Okay, that. Oh, okay. Okay, I can use any other installation version. Okay, so I can deprecate to the previous versions as well. So currently my Jupyter Notebook engine is running. So let's just test environment. Maybe this should do. I'm already running an engine. I don't know if that uh, matches with the existing one. Okay, so this creates one with some default packages. Okay. Uh, wait. Okay. And then I have to connect something like this. It's a launch repeater from. Why is it does it show that I've not installed it yet? I have it installed. Okay. So this will take some additional space in my memory. Maybe I don't want it. Honda. Okay. Yeah. Sorry, come again, please. It's yes, yes. Okay, so when I delete it, it will go away. Okay, okay, I understood your point. Yes. So this one, when I change it to root, it shows Jupyter Notebook and PyCharm already installed. But for this test environment, these are not. And as soon as I delete the test environment, whatever things I install, that will go away. Okay, got your point. Thanks, Shad. This is really
Yeah, but the kernel term is the most confusing term, right? Like here it's a kernel,
yes.
and then SVM also there are some kernels.
Kernel tricks, yes. In
Kernel
SVM
trick.
and logistic regression, in linear regression, there are kernels.
Yeah, everywhere kernels, but every kernel is something different.
Today I just was reviewing the Kudoku game which we were assigned to make. This one is
Oh.
not running properly, but they still gave me 9 marks on it. I was really thankful for the TA who gave me the marks. At least I had
ML.
something. No, it is the ACI.
Oh, ACI guys, you are topper, like talented guys. We didn't avail that.
I hardly got 11 marks out of 40 in ACI.
Oh, yeah, that's
Me
fine.
too, me.
Yeah.
I got 10.
And what about those other evaluation, EC1, EC2? Are you going to start that?
I know it, I forgot and have